Good afternoon, students.
Uh,
Okay, all of you please switch on your videos. So as commenced earlier, today we are going to start the physics seminar sessions. So I think the first one is not present today. Afsan, are you ready for taking seminar? Unmute and say. Okay. So anyway, we can start with Aditya. He is ready to take the seminar. So all of you listen here, what he present here. After the seminar session, you can ask doubt to him. And Aditya, you can ask question to your friends. And after the seminar, we have some 5 minutes discussion based on the topic. Okay. So let us start. Okay, Aditya, now you can start the session. Did you prepare any PowerPoint?
yes, ma'am.
Okay, I will share the screen.
I need to share.
Yes, Aditya?
I need to share.
Yes.
He need to share this screen.
Okay, all right.
I'm going to do a seminar on the chapter Human Eye and the Colorful World and the specific topic effects of vision and their correction. So what are the effects of vision? So there are three main common types of effects for vision. So can anyone tell what are the three main common defects of vision? Anyone?
Myopia.
Okay. Savi, can you answer? I didn't hear. Okay, first, this is myopia and
Hypermetropia.
hypermetropia and yeah, presbyopia. Correct. So these are the three main common defects of vision. Now we look in depth of what are the three defects. First, we'll start with myopia. So what is myopia? Just in simple words, can you tell what is myopia?
Short sight.
Yeah, short sight or nearsightedness. A person with myopia can see nearby objects clearly, but cannot see distant objects. In a myopic eye, the image of the distant object is formed in front of the retina. Effect may arise due to, can someone tell how this can be caused? Any one reason? Okay, it can be caused due to the excessive curvature of the eyelids, and it's also caused by the elongation of the eyeball. So then we have the correction. So can someone tell how can we correct this defect? Yeah, with the concave lens. Thank you, Aditya. With a concave lens of suitable power will bring the image back onto the retina, and thus the defect is corrected. Now we are going to look at hypermetropia. So Again, what is hypermetropia in simple words?
Long sight.
Yeah, it's long sight or farsightedness. A person with hypermetropia can see distant objects clearly but cannot see nearby objects. The near point for this kind of eye is farther away from the normal near point, uh, about 25 centimeters. This is because the light rays from a of a close by object are focused at the point behind the retina. So the image is what behind the retina. So this effect may arise due to the focal length of the eye. The focal length of the eye is too long and the eyeball has become too small. So how can we correct this kind of effect?
Convex lens.
Yeah, uh, this effect can be corrected using a convex lens. Eyeglasses with converging lenses provide the additional focusing power required for forming the image on the retina. Now we look at the last effect, which is presbyopia. So, in simple words, wait, what is presbyopia? Like, Roman? Okay, the power of accommodation of the eye usually decreases with aging. For most people, the near point of the eye gradually recedes away. This defect is called presbyopia. Sometimes a person may suffer from myopia and hypermetropia. So, with presbyopia, you will have both myopia and hypermetropia as well. So, this defect may arise due to the gradual weakening of the eye lens. So, how can we correct this defect? Can anyone say?
Question.
Huh?
What is the question?
How can we correct the presbyopia? It's a specific type of lens. Okay, I'll explain. Uh, uh, these people require a bifocal lens. So bifocal lens consists both a concave lens and a convex lens. The upper portion is a concave lens. It facilitates distant vision, and in the lower part, it has a concave lens. Right? It has a convex lens, sorry, that's a mistake. And it facilitates near vision. Thank you.
Is it over?
Yes, ma'am.
Okay, dear. Anyway, it's a nice presentation. Give him a clap. Good, very good. So now we have a discussion based on this topic. Aditya, you can ask the doubt. If anyone have the doubt, you can ask and clarify it with him. What about others? Do you have any doubt? You can ask him. No problem.
No doubt, ma'am.
Everything is clear. And Aditya, now you can ask any one or two questions to your friends. We want to check whether they are listening or not.
Okay. So, how can we correct? No, Someone said what was presbyopia. Can someone tell what is presbyopia?
You can call the name, no problem.
Okay. Fa-
Will you
Rifa.
repeat the question?
What is presbyopia?
That we will, as we aging, our eyesight will get reduced or fade away.
Yeah, our islands will.
And how it is happens, dear? How it is happens?
Ma'am, with aging, as we get older,
Yes.
it will become very weak.
Which one? The eye or eyelids?
Our eyesight.
Okay, the islands become weak and the ability of power of accommodation will be lost. So
Lost.
presbyopia means it is the gradual weakening of the islands. So what happens is that after that the islands lose the ability to control the focal length with the help of ciliary muscles. The ciliary muscles are said to be weak during old age. So that defect of the eye is known as presbyopia. And how we can correct the presbyopia? Arjun? How we can correct presbyopia?
Using both the concave and
Very good. By using bifocal lens. By the term bifocal lens, we mean that the upper part is made with concave and the lower part with the convex. Is there any other questions? Aditya?
How is myopia? What causes myopia?
Okay. To whom? Is it to Savio? Savio, I think he's ready to say the answer.
Okay, then Xavier can.
increasing temperature of the island,
One more, please.
increasing the length of the island.
Yeah, correct.
Okay. Any more questions? I think it's enough, dear. Anyway, good. Good, nice presentation. Thank you. Then who is next? Aditya? Aditya, yes.
Yes, ma'am.
Okay. What about your seminar paper? Are you ready to present today?
I have one more topic to complete after that.
What's your topic?
Dispersion of light. In that, how rainbow is formed, I have not done that. So,
Okay. Then what about Adil Muhammad? Students, in the last class we were discussing about Ohm's law and the statement of Ohm's law, mathematical representation of Ohm's law, and we were discussing about resistance and what is the SI unit of resistance and what is the importance of resistance in Ohm's law and all. So once again we can recall all these points and we can move to the next topic. So for that I will call Vishnupriya. Vishnupriya, please state Ohm's law. State Ohm's law.
Ohm's law states the relationship between resistance, current, and potential.
Yes, it is the relationship between the current and potential difference. And what define Ohm's law or state Ohm's law?
Ohm's law states that the potential difference between 2 points in an electric conductor is directly proportional to the current flowing.
Current flowing through it by providing one condition. What is that condition?
The temperature and the others remain constant.
By providing the temperature remains a constant. So according to Ohm's law, the potential difference across the ends of a conductor, the potential difference across the ends of a conductor in an electric circuit is directly proportional to the current flowing through it by providing the temperature remains a constant. So according to this law, we can write the equation V is directly proportional to I, and we have a tendency to replace this proportionality sign. So we introduce a constant. That constant is known as resistance. So what is the mathematical representation for Ohm's law? Pratyush, what is the mathematical representation of Ohm's law? Mathematical equation for calculating Ohm's law. Very good, Savio. V is equal to IR. And what is this R stands for? Badra, what is this R stands for?
Resistance.
Resistance. Can you define what you mean by resistance?
It is the property of a conductor to resist the flow of charges flowing through it.
Okay, it is the property that resists the flow of current through a circuit is known as resistance. And what is the SI unit of resistance? Anne Mary, SI unit of resistance. Yes. SI unit of resistance, it's not clear. Can you say it once again?
Ohm.
Ohm. Okay, and it is represented by a Greek symbol. So that is what we were discussing in our last class. So today we are going to see the electrical resistance offered by the different components with the help of an activity. So the activity is there in your textbook, page number 205. So with the help of an activity 12.2 in page number 205, we can check the electrical resistance offered by the different components. Are you ready? Okay, so let us start. Page number 205. Page number 205, activity 12.2. So in order to do this activity, here we consider some electrical components. They are cell. What is this represents? This one? Yes? Any idea?
Cell.
It is the cell or the battery. Okay, the combination of cell or the battery, and it is possess two terminals. What are they?
Positive and negative terminal.
Positive and negative terminal. And this red symbol is represents red.
Negative.
Red represent negative.
Positive.
Oh, if it is not negative, then it is positive. So the red color indicates the positive terminal. Okay, and what about this blue terminal?
Negative.
It represents the negative. All right. Okay, so here we consider an ammeter, the battery, and here there is a key. So we can connect all these components here. So the positive terminal of the battery is connected to where? Positive terminal is connected to ammeter. Actually, it is connected to the positive terminal of the ammeter, but unfortunately it is the negative. So you just cooperate. It is our, okay, we can connect this wire to here.
Yes,
the positive terminal of the battery is connected to the positive terminal of the ammeter. Okay?
Positive.
Ah, yes. Here the positive terminal of the battery goes to positive. Okay. Now here the negative terminal of the battery is connected to where?
Negative.
The negative
Key.
terminal is connected to key. The key is represented by a dot inside a bracket, and then from this key there is a connection, and here we are leaves the gap between here. We need to connect some conductors there in order to check the resistance, and the end of this wire is connected to the negative terminal of the ammeter. Okay. So here we can use the wire joint. Can we draw like this? Is it possible? No. So instead of that, here we can do another arrangement. What is that? A hump-like structure. Is it clear? Is it clear now? So this is the connection that we are made here. So in order to do this activity, here we use ammeter, the cell, and the key, and here we leave a gap. We can name that gap as X and Y. And here we consider three conductors. What are the three conductors?
Chrome wire.
The first one is a nichrome wire. Nichrome wire. The second one? 10 watt bulb. Very good. 10 watt bulb. The third component? It is a torch bulb. So we are going to connect these three components one by one in that gap, and we can measure the value of current produced here. So first we are going to connect nichrome wire. First we are going to connect this nichrome wire, the gap between X and Y. Okay, so we can give another color for this nichrome wire. Okay, so here I am used to connect the nichrome wire. Now the circuit is open or closed? What is the condition of the circuit? Is it is open or closed?
circuit.
Now it is a closed circuit, right? So here I am used to connect the nichrome wire. So what happens? The current is started to flow from positive terminal to negative terminal, and we can measure the value of the current with the help of a device connected here. What is that device?
Ammeter.
With the help of ammeter. Okay, with the help of ammeter we can measure the value of current. And suppose students, we are measure the value of current as here. The meter pointer is marked towards here. What is it represent? This is milliampere. Here 0, 1, 2, 3. Here it is pointing towards here. Between 0 and 1. 1 by 2 or 0.5, right? Here the value of the current is pointing towards here in the ammeter. That is 0.5 ampere, right? It is 0.5 ampere. Okay, so when we connect the nichrome wire, the current is flowing through the circuit, and we measure the value of the current with the help of an ammeter, and it is 0.5 ampere. Okay, now we can remove this nichrome wire. Before that, we want to remove the key from the plug. Okay, here we want to remove the key from the plug. So students, when you do the experiment, you must note that after each reading the value, you must take this key from this plug. You must remove the key from the plug. Okay. Now here we are going to remove this nichrome wire from this gap between X and Y. And here we are used to connect what? Here we are used to connect the second component. What is the second component?
10-volt bulb.
It is a 10-volt bulb. Okay, so here I am used to connect a 10-volt bulb here. Okay, so here I am connecting a 10-volt bulb.
Yes, ma'am.
Okay. Now again, does the current flows through the circuit? Is it closed?
No, ma'am. Key.
It is very good. It is open state. Why? Because here we are removing the key from the plug. And so in this state, the circuit is said to be open. The circuit is closed if and only if we are insert the key into the plug. So now the circuit is closed, right? Now the circuit is closed. So what happens? The bulb is started to glow. Again we note the ammeter. So here the current is started to flow from positive terminal to negative terminal, and the bulb is started to glow. So we can measure the value of the current with the help of an ammeter, and now this time the ammeter reading is pointing this direction. What's the value? It is 2 ampere. It is 2 ampere. So when we connect a 10-watt bulb in the place of nichrome wire, we replace the nichrome wire with the help of a 10-watt bulb, and we repeat the same activity, and we measure the value of current through the electric circuit, and it is 2 ampere. It is 2 ampere. Now again, what is the next step? The first step is you remove the key from the plug. Then we can replace this bulb. Okay, now we are going to replace the bulb. How we can replace the bulb? 1 minute. Okay. Now here we are replacing that 10 volt bulb, and instead of this 10 volt bulb, what we are going to place there? The third component. What is that?
Torch bulb.
It is a torch bulb. So you just imagine this is our torch bulb. This is the symbol to represent the bulb. Okay. So here we are connecting a torch bulb here in this gap. Then again the circuit is open, it is closed if and only if we are insert the key into the plug. Now the circuit is closed, so the current is started to flow from positive terminal to negative terminal. Then again we repeat the same procedure, measure the value of the current with the help of an ammeter. Now during this time, suppose the ammeter reading shows or point towards here. What's the value? It is 3 ampere. It is 3 ampere. So when we are connecting the torch bulb in that gap, we get 3 ampere current. Okay. So here we consider the 3 different components. One is a nichrome wire, the second one is a 10 watt bulb, and the third one is the torch bulb. So when we connect all these 3 different components to the electric circuit, we get different values for the current, right? Does we get the same values for the current or different values? We get the different values for the current. And through which component more current flow is occurs? Yes, it is through torch bulb. So, and through which component the less current or least current flow will occurs? It is through the nichrome wire. And students, from this it is clear that the current that is flowing through different components are different. And according to Ohm's law, we studied that the voltage V is equal to IR, or we can write R is equal to V by I. That is, R is the resistance, V is the potential, I is the current. And from this equation it is clear that the resistance and current are inversely proportional to each other, right? The resistance and current are inversely proportional to each other. That is, if the value of the current increases, what happens to the value of resistance? Is it increase or decrease? Here, the value of resistance is inversely proportional to current. So my question is this: if the value of the current increases, what happens to the value of resistance? Is it increase or decrease?
Yes.
It is decrease, because they are inversely proportional. They are not directly proportional. Resistance and current are inversely proportional to each other. So here, from this we can say that the torch bulb, through the torch bulb, more current flow is occurs through the torch bulb. So what about the value of resistance there? Is it is more or less? Here the torch bulb possesses a less value of resistance. It possesses a less value of resistance. Then what about the case of nichrome wire? Through the nichrome wire, very less amount of current flow occurs. So what about the value of resistance there? Is it is less or more? Here the nichrome wire possesses a more value of resistance. It possesses a more value of resistance. So from this activity it is clear that different components possess different electrical resistance, okay, or through different components different amount of current flow is occurs. It is because of their electrical resistance. The different electrical components possess different electrical resistance. That is why different amount of the current flowing through these components. Is it clear?
Yes.
Certain components are possess an easy path for the flow of current. Here we can see the torch bulb. It possesses an easy path for the flow of current, and in the case of torch bulb it has a less resistance. So such type of components are called conductors. So what do you mean by conductors? Conductors are the substances that possess easy path for the flow of current. So all of you write the heading conductors. So we are going to differentiate between conductors and insulators. Conductors and insulators. Write the next subheading, conductors. What do you mean by conductors? Components which offer components, or not components, components. The components which offer an easy path for the flow of current. Components which offer an easy path for the flow of current components which offer an easy path for the flow of current are called conductors. Components which offer an easy path for the flow of current are called conductors. And what about the resistance of the conductors?
Less.
Yes, they have a less value of resistance. They have a less value of resistance. They have a less value of resistance. And one more point associated with these conductors, they obeys Ohm's law. They obeys Ohm's law. They obeys Ohm's law. Okay. So conductors are the components which offer an easy path for the flow of current because they have a less resistance, so they obeys the Ohm's law. Is it clear?
Yes, ma'am.
Yes, ma'am.
But there are certain components which offers less path, or the easy flow of the current is not takes place with the
Indicators.
yes. Such components are known as insulators. Such components are known as insulators. So all of you write the next heading, insulators. Insulators. Guys, can you form a definition for this insulators? What do you mean by
Will you show the
insulators?
last slide one more time?
Sorry dear, I rub it. Which one you are need?
And conductors.
Okay, conductors are the components which offer an easy path for the flow of current. Conductors are the components which offer an easy path for the flow of current. They have less resistance and they obey Ohm's law. They obeys Ohm's law. Conductors are the components which offer an easy path. And what do you mean by insulators? These are the components,
Easy path.
yes, which do not offer, yes, which do not offer the easy path for the flow of current. Components which do not offer an easy path, for the flow of current. For the flow of current through it are called insulators. What about their resistance value?
High resistance value.
Yes, they have high resistance. They have high value of resistance.
They do not obey Ohm's law.
Yes, very good, excellent. They have high value of resistance and they do not obey Ohm's law. They do not obey Ohm's law. So these are the classification between the conductors and insulators. So from this activity, the activity 12.2, we can say that the different components offer different electrical resistance, or some components are possess an easy path for the flow of current through it, but some other components are do not possess an easy path for the flow of current. So depending upon that, we can classify the components into two. One is conductors and other is insulators. Conductors are the components which offer an easy path for the flow of current. They have a less value of resistance and they obey the Ohm's law. Whereas insulators are the components which do not offer an easy path for the flow of current and they have high value of resistance and they do not obey the Ohm's law. Can you say some examples for insulators? Yes.
Rose.
Yes. Yes, very good. Wood, plastic, glass, these are examples for insulators. What about the conductors? Can you say some examples? Metals. Most of the metals are conductors. Almost all the metals are conductors. Okay. So with this we are complete that portion of Ohm's law. So based on the Ohm's law we can classify the components into conductors and insulators. Is it clear?
Yes, ma'am.
Okay. So it's the time. Let me take your attendance. Have a nice day. Thank you.
Thank you, ma'am.